All right, I want to look at some examples where we're solving an equation, but in the equation, there's a coefficient on theta or x or whatever our variable is for our angle. And so first up, I want to look at this example here that I've called a teaching example. Sine 5x equals a half. So before we do that, let's look at Desmos for a minute. All right, so I've got y equals sine x and y equals 1/2, both graphed here. And I'm going to come up here and I'm going to restrict this. I can put x or 0 is less than or equal to x is less than or equal to 2 pi. That way, we've only got the portion of the graph that we're interested in. And if this, notice right now I've just got an x there, not the 5x. So if we look at the graph over here, there are only two solutions, which is what we'd expect, one at pi over 6 and one at 5 pi over 6. If I change this up here, though, to 5x, notice we get a bunch more solutions. We get, well, let's see. What do we get there? Is that 10 solutions? 2, 4, 6, 8, 10. Yeah. So what I want to do is look at how to find all 10 of these solutions that lie between 0 and 2 pi. So here's what we'll do. First up, I'm going to write this down for this one. You don't have to write this on every single problem, but I'm going to do a substitution. Let u, or better yet, let theta equal 5x. So we're just going to substitute that in, and now we're going to solve sine theta equals 1/2. Okay, so this is just like what we did before. If sine theta is 1/2, we know that the theta reference angle is going to be pi over 6, and we're going to be in quadrants 1 and 2. So that gives me solutions of theta is equal to, in quadrant 1 it'll be pi over 6, and in quadrant 2 we would get 5 pi over 6. And I'm going to go ahead and put the plus 2 pi in here. So we go through here and we find all of the solutions, not just the ones that lie, not just the solutions here that would lie between 0 and 2 pi. But now what we need to do is, for each one of these, we need to replace the theta with 5x. So this one becomes 5x equals pi over 6 plus 2 pi n. And the other one becomes 5x equals 5 pi over 6 plus 2 pi n. So we get these, and then we're solving for x, so all we've got to do now is divide by 5. So divide everything by 5. All right, so let's see. This one becomes x equals, let's see, pi over 6. When you divide that by 5, you get pi over 30 plus 2 pi over 5 times n. And then over here you get x equals 5 pi over 30 plus 2 pi n over 5. So that's a recipe for all the solutions. We call this a general solution. And so that'll get us all the solutions to this thing. Now, what we're asked to do here, though, is they ask us to find the, or solve the equation on the interval from 0 to 2 pi. So what we want to do is list all of the solutions that lie in that interval. And I almost didn't give myself enough room. Between 0 and 2 pi. All right, here's the easiest way to do that. Grab a calculator. And so for pi over 30, we'll start with that. And what I'm going to do, I'm going to leave the pi off on my calculator. I'm going to put 1 over 30. I'm going to put in 1 over 30 here. And I'm going to start adding 2/5 onto it. Why 2/5? Well, we're supposed to add 2/5 pi onto it. So I've got the pi with a 1 over 30, and I'm going to start adding 2/5 onto it. So let me pull this back up. So notice how I've got that answer plus 2/5 convert to fraction. So we get 13 over 30, 5 over 6, 37 over 30, 49 over 30, and then 61 over 30. Now 61 over 30 is bigger than 2. So these are all my coefficients for pi for my solutions. So my solutions are going to be pi over 30, 13 over 30, 13 pi over 30, 5 pi over 6, 37 pi over 30, 49 pi over 30, and then 61 pi over 30, that's a solution, but it's not inside the interval. So that's all we get from our first answer, from the pi over 30. Now 5 pi over 30, I'm going to do the same thing. I'm going to try to do this where you can see it. So I'm going to put in 5 over 30, hit enter. That gives me this. Then I'm just going to do plus 2/5, and then math frac. So math, and then 1 for frac. And when I hit enter, this is going to give me all the other solutions. So 17 over 30, 29, 41, 53. And that's going to be the last one because the next one is 13 over 6, and that's bigger than 2. Remember, these are coefficients, and we only want to go up to 2. So these other solutions are 5 pi over 30, 17 pi over 30. Notice the next one, if we're adding 6 onto that, or not 6, anyway, the next one's 29 pi over 30, 53 pi over 30, and then 13 pi over 6, which I'm not going to list. Now, why don't we get 4 there and I got 5 on the other? But because I completely left out, I skipped 41. All right. So those are all the solutions to this equation that lie between 0 and 2 pi. Let's see, how many more of these do we need to do? I've got 2 more examples. All right, let's do this one. Cosine of x, 11/4 x equals 1/2. All right, so first up, cosine of theta is 1/2. And which angles have a cosine of 1/2? Well, let's see, cosine of 60 degrees is 1/2. So 60 degrees is pi over 3. And let's see, reference angles, ASTC, we want to put one there, and we want to put one there. So we'll get the pi over 3 and negative pi over 3. It's okay to use negative pi over 3 here instead of going around and calling it, what would it be? Well, instead of going around and getting 5 pi over 3. It's perfectly fine to leave it like this, because what we're going to do here is we're going to add, when we start adding the 2 pi's on, we'll just collect all the solutions in the end that lie between 0 and 2 pi. So let's see, remember these were our answers for theta, but we want x. So let me move this over. So theta, we get 11 pi, or 11x over 4 is equal to these two things. So x is going to be 4 pi over 33 plus 8 pi n over 11. And over here, x is equal to negative 4 pi over 33 plus 8 pi n over 11. All right, and so we're pretty much done with the actual work part of this. The rest of it we'll do on the calculator. What I'm going to do on the calculator is I'm going to start with this. I'm going to do 4 over 33, and then I'm going to add multiples of 8 over 11. So let's see, 4 over 33 Right, so I've got this here, and I want to keep adding these on until our answer gets bigger than 2. Okay, 76 over 33, that's bigger than 2. So the solutions we get from this are four pi over 33, 28 pi over 33, 52 pi over 33. That's all we get from that. Then for the other one, we're going to start with negative 4 over 33 and add 8 over 11 to it. So let's see, we get 20 over 33, 4/3, 68 over 33. That's bigger than 2. So we don't need that one. We only get 2 of these solutions, it looks like. So 20 over 33 pi and 4 pi over 3. So interesting, we get 5 solutions here. Let's look at this on Desmos and see that that's actually what we get. Let's see, I'm going to bring this up. Whoop, not that. Okay, what was the equation we had? Cosine of 11x over 4. And that was equal to 1/2. All right, and let's restrict this to just go between 0, 2 pi. All right, so how many solutions do we get here? Looks like we get 1, 2, 3, 4, 5 total. And sure enough, that's what we got up here. We got 5 solutions. Let's see if the fractions are nice enough that it can give it to us. No, it's not giving it to us as multiples of pi, but 0.381. If I look at this and do 4 pi over 33, yeah, sure enough, that gives me 0.38077. So that gives me the first one. And so that gives me the 5 solutions that we found using the doing it by hand. All right, this video is getting long, so I'm going to save the next example for the next video.